For this problem, we're given the Poisson process, and this is the probability for that. It's this formula here. And now we defined x of t, and it's equivalent to 1 if n is odd in this formula, in this process. And it's equivalent to -1 if it is even in this process. So you can write that out as basically this is the sum of all of these, and if it is odd, then k will be odd. So basically you could write that out as e to the lambda t, negative lambda t. We're plugging and chugging here. And you plug in that for that, you get lambda t plus lambda t to the third over 6, and that continues for every odd value of k. Now, if you look at this is equivalent to that. So basically it is the hyperbolic sine of lambda t multiplied by e to the negative lambda t. Hyperbolic sine is equivalent to e to the it's equivalent to e to the x plus e to the minus x over 2. If you substitute in lambda t, you get this. And now we multiply that out, and basically we see that the negative lambda t and lambda t cancel into 1, and the other one, it doubles. So we get the answer of 1 minus e to the negative 2 lambda t all over 2. So now we're given to find the expected value of x of t. In order to do that, we first have to find the probability that x of t is equivalent to -1. So that, from what we're saying, is that k is even. So again, we go through the same exact process before. We write it out, and basically it comes down to this. So e to the negative t plus times the quantity of 1 plus ... for every even value of k. Now that is equivalent to e to the negative lambda t hyperbolic cosine of lambda t. So again, we substitute what the hyperbolic cosine is, and it's the same as sine except for there's a plus. So if we multiply these out again, it cancels again into 1, except for this one is plus e to the negative 2 lambda t, and this is all over 2 as well. So the expected value of x of t is the first probability that we solve for, plus the negative of the second probability that we found. So basically, if you do the math here and do that, so basically we see that the ones cancel. The e to the negative 2 lambda t, they add, so we get -2 e to the negative lambda t over 2, which comes out to e to the negative lambda t. For part C, we're looking for the autocorrelation, so it's equivalent to the expected value of x of t1 times the x of t2. So the probability of x, which is equivalent to the probability of x of t1 times x of t2, and that is equal to 1, which means k is odd, plus the probability of x of t1 times x of t2 is equal to -1, which means k is even, and it's plus the negative. So we write that out, we rewrite it to just make it a minus. This leads to what we found previously. So it is probability of x of t is equal to -1 minus the probability of x of t is equal to -1. We substitute t for t2 minus t1, and we do some math, and we get this result. So that result is going to be valid. You'll get that result regardless of whether or not t2 or t1 is larger. It is not wide sense stationary, because the expected value of x of t is a function of t, which is not constant, which removes the possibility of it being wide sense stationary.